This is the screencast for conceptual objective number 2. It's found on page 52, and the question is number 60. So I already began by writing what we are given, what we need, and the physical property, which is constant acceleration. Here's my picture. That is a car. It shows that we are going in this direction. This is our initial velocity. This is our displacement. And then our final velocity will be right here. So since we identified this as a constant acceleration problem, there's a simple way that I use to figure out which equation to use. So I write down all of the variables that are found in constant acceleration problems, which include displacement, v0, t, v, a. And so you start by making a dot underneath the one that you need. So we're first going to try and find A, and then put a dot under everything you have. So we have displacement, we have v0, and we have v. So now we use the equation that uses those four things. So I chose v squared equals v0 squared plus 2 times A times displacement. Alright, so now we just plug it in. So 6.4 squared meters per second equals 8.4 squared meters per second plus 2 times A times displacement, which is 7.2 meters. So first we're going to figure out what these are. So this is 40.96 meters per second, and this is 70.56 meters per second. And so since this is the first part of the problem, we're just going to do that right now. So minus 70.56 meters per second, minus 70.56, and we get negative 29.6 meters per second equals 2 times A, 7.2 meters. And now we're going to try and get A alone, so we divide by 7.2 meters, and we get negative 4.11 equals 2A divided by 2. And now our acceleration is negative 2.05 meters per second squared. Alright, so now we can write that up in our given. Okay, so now the second part of the question is what's the time that it takes to travel this little patch right here. So now we can find another equation. So maybe we can just write this off in the corner over here. I can use a different color. Okay. So change in x, v0, t, v, and a. Okay, so we're trying to find t, so that's the first thing. And then we do have everything else. So pretty much you get to decide which one you get to use. So I'm going to choose v equals v0 plus at. So now we just plug it in. So 6.4 equals 8.4 plus negative 2.05 meters per second squared. Probably should put that meters per second times t. So we're going to start by subtracting 8.4 from both sides, and we get negative 2 equals negative 2.05 times t. So now we get t alone by dividing by negative 2.05. So now t equals 0.976. 976 seconds. So now we're going to write that up here. Okay, now the second part to this question asks, what if the initial was 5.4 meters per second instead of 8.4 meters per second? And would this produce a final velocity of 3.4 meters per second? Because you see how this is exactly